Welcome to The Explainer. Today, we're going to tackle a core concept in programming that, let's be honest, trips a lot of people up, especially on exams: polymorphism. We're really going to lock down the difference between overloading and overriding.
So, let's start with a simple question that really gets to the heart of what we're talking about today. How is it possible for one single name to have many different forms?
Well, the answer is this really powerful idea called polymorphism. It literally means many forms. It's a Greek word. And in the world of code, this means we can have one name for something, but it can perform multiple functions. It's what makes our code so flexible.
Okay, so check out the code here, specifically that second line. We have a variable of type animal, the parent class, but it's actually pointing to a dog object, which is the child class. This is polymorphism in a nutshell. The dog2 object can be treated like any other animal, but underneath it's still a dog. This ability to wear two hats, so to speak, is totally fundamental.
Now, what's really interesting is that polymorphism isn't just one thing. It actually comes in two main flavors. And knowing the difference, well, that's absolutely crucial, especially when you're trying to figure out what a piece of code is going to do. So you've got static polymorphism, which is also called compile-time polymorphism. The what-to-do decision is made when you compile your code, and we get this through something called method overloading. And then you have dynamic polymorphism, or runtime polymorphism. Here the decision gets postponed until the program is actually running, and this is done using method overriding.
All right, let's dive into the first type, method overloading. The easiest way to think about this is giving one method name a bunch of different jobs inside the very same class.
Take a look at this calculator class. We've got two methods, and they're both called add. But here's the key, right? Look at the difference. The first one takes two integers. The second one takes a double and an integer. So same name, but a different list of ingredients, or what programmers call a different method signature. So you might be asking, how does the program know which add method to use? Well, it's pretty simple, actually. The compiler just looks at the types of arguments you give it. You pass in two integers, bam, it knows to use the first add method. You give it a double and an integer, it knows to use the second one. And this all happens before the program even starts running. All right, here's a quick pop quiz for you. Based on the code we just saw, pause here for a sec and try to predict what the output's going to be. What will this program print? And there it is. If you guessed 11 and 13.2, you are absolutely right. You nailed it. The compiler knew exactly which method to pick for each job. That is static polymorphism for you. So here's the main takeaway for overloading, the thing you really need to remember. It is all about the method signature. You have to have the same name, but the list of parameters has to be different, either a different number of them or different types. And as you can see, other things like the return type can be different too. Okay, let's switch gears and talk about our second type, dynamic polymorphism, which we get through method overriding. Now this is different because it doesn't happen in one class. It happens between two classes that have a parent-child relationship. On the left, we've got a general animal class with a method called eat. And over on the right, you see the cat class. It's a child of animal, and it provides its own more specific version of that exact same eat method. It's basically saying, hey, I know what you taught me that, but I'm going to do it my way. That's overriding. Okay, so let's see what happens when we put this code into action. We make three objects, a regular animal, a regular cat, but pay close attention to that third one. It's an animal reference, but it's pointing to a cat object. Then we call the eat method on all three of them. All right, another classic exam-style question for you. Take a second, pause and think. What do you think this code is going to print out? So, did you get it? Let's check the result. The first two, pretty straightforward. But that third one is where the magic happens. Even though the variable object is type animal, the program prints a cat eats. So why? Because at runtime, when the code is actually executing, the system looks at the real object, which is a cat, and it calls the cat's version of the method. And this is a perfect example of the rules for overwriting. The method signature, the name and the parameters has to be exactly the same. It has to happen in a subclass. And here's a big one. You can't make the new method more private. And remember, you absolutely cannot override methods that are final or static. They're locked down. All right, we've looked at both. Now it's time for the showdown. Let's put them head to head and make this crystal clear. Okay, this slide right here, this is your key takeaway.
This is the cheat sheet you need. Overloading. It's all happening in the same class, it needs different parameters, and the decision is made at compile time. Overriding, it's between two classes in an inheritance relationship, it needs the same parameters, and the decision is made at runtime. Got it?
So you might be thinking, okay, that's cool, but why does any of this really matter? What's the bigger picture here? Well, it all comes down to being able to write more flexible and powerful code using a concept called abstraction. Method overriding is basically the engine that powers abstraction. It lets us create a general contract or a blueprint for something, like an interface, without having to spell out every single detail. It's like drawing up the plans for a house without actually building it. And this right here is a perfect illustration of that idea. On the left, that code is illegal. You can't just create an iPet because it's only a blueprint, a set of rules. But on the right, the code works just fine because we're creating a dog object, which is a real, concrete thing that promises to follow all the rules laid out in that iPad blueprint. And this quote really nails it. It's the contract in action. If a class says, I'm going to follow this blueprint, then it's on the hook. It has to provide the real concrete details for all the abstract parts of that blueprint. So we're going to leave you with this final question to chew on. Now that you know the difference, think about a real project you might work on. When would you make the call to overload a method to give it multiple jobs? And when would you choose to override one to change how a child class behaves? Knowing the answer to that is what separates good programmers from great ones.